Alright guys, today we're going to talk about partial fraction decomposition and what is partial fraction decomposition. So a long time ago someone taught you 1/2 plus 1/7, and they asked you to add these two things and create one fraction. Okay, so that was, elementary school. Take two fractions, combine them into one. Now what were you to do? You were to find a common denominator. Well, a common denominator between 2 and 7 is 14. And so you'd come in and say, okay, well, this times 7 gives me 14. And this times 2 gives me 14. And since I multiplied that by 7, I've got to multiply that by 7. So I get that. And multiply that by 2. So I've got to multiply that by 2. So I get that, right? And what do we end up with, right? We end up with something, if I take these two and add them together, around the lines of 9/14. Okay. Now, partial fraction decomposition is this same concept, except I give you that. You're taking a single fraction and breaking it into two. Now, since this has factors of 7 and 2, we assume one of these has a denominator of 7 and one has a denominator of 2, and we'll set these to x and y, or in this case a and b, and you'll solve for a and b. Okay, that is the idea behind partial fraction decomposition. You take a fraction and you break it into two or more smaller fractions. There is a catch. The catch is we are not going to do this with numbers. We do it with rational functions. So there are three scenarios when doing partial fraction decomposition. I'm going to cover all three with you today. So let's start with the first one here. I'm going to give you 5x minus 3 over x squared minus 2x minus 3. And we will be asked to decompose these fractions. Okay, so first step is we're going to factor this. And this factors to x minus 3 and x plus 1. Now what I need you to note is that these are two unique factors. Okay, so two unique factors. Okay, that's important because that's going to be a different setup than if we have two non-unique factors. Okay, so now here's going to be our setup. We're going to take this fraction and we're going to say, since we got two factors, one of these denominators will be x minus 3, one will be x plus 1, and we don't know what the numerators are, and so we're going to pick a and b. Okay, this is what our answer will look like. Now I'm going to come in pencil, and what I'm going to do is I'm going to treat this like I would an elementary school fraction problem. Is that for this and this to give me this, I have to have a common denominator. So this is going to be times x plus 1, and this is going to be times x minus 3 over x minus 3. Okay. Now, because this, and this are all equal, i.e. the term common denominator, we don't really care about the denominator. We really only care about the numerator. And so what's going to happen is we're going to take our numerator, just our numerator, and what we're going to do is we're going to say 5x minus 3 is equal to a x plus 1 plus b x minus 3. Okay. Now I'm going to go ahead and distribute. So that's going to give me 5x minus 3 equals ax plus a plus bx minus 3b. Now I'm going to play a little trick. I'm going to play a little game. That is, if I look at this equation, those three terms are like terms. Similarly, these three terms are like terms. So what I'm going to do is I'm going to set up a system of equations. System of equations. And the idea is I'm going to only use like terms. So I'm going to take 5x, ax, and bx and say, listen, 5 has to equal a plus b. And then I'm going to take this negative 3 and this a and this minus 3b and say negative 3 has to equal a minus 3b. Okay? Now I'm going to solve that system of equations. And I'm going to be really lazy in the fact that if I take these two systems here and I subtract, a minus a gives me 0, and b minus negative 3b gives me 4b, and 5 minus negative 3 gives me 8, and so I get b equals 2. And then if I sub that back in here, if that's 2, that has to be 3 to give me 5. So a is 3. Boom. So now I know A and I know B. So now I have my answer. Here's my answer. Okay? My answer is 5x minus 3 over x squared minus 2x minus 3 equals, and I'm going to come back up here and everything that I wrote in blue, I'm going to rewrite. Only where I have A, I'm going to put 3. And where I have b, I'm going to put 2. And that is my partial fraction decomposition for this fraction. And this is going to be the same every time that you have a rational function with non-repeating unique linear factors. Okay? So these are unique factors. They're not repeating, okay, and they're both linear. So let's try another one. Next scenario. Okay? So here goes. And let me not write that. I don't want to write it in blue because I'm going to save the blue pen for something else. I'm going to save the blue pen for something else. Okay? So here goes. Our second scenario. Okay, here's our second scenario. I have got x squared minus 4x plus 7 over x minus 3 cubed. Okay? Now, if I take this and I ask you what are the factors, okay, what are they? They're x minus 3 times x minus 3 times x minus 3, okay? No different than if I asked you the factors of 8 and you said, oh, that's 2, 2, and 2, okay? These would be repeating linear factors, okay? Whenever you have repeating factors like this, you basically have to list every power of the factor. So for an example, if we used 8 equals 2 times 2 times 2, then your denominators would be 2, 4, and 8, which is 2 to the first, 2 to the second, and 2 to the third. Okay? Those would be your three denominators. So here, okay, and you'll see that I always like to write my partial fraction decomposition in a color. And the reason I do that is because the part that I write in blue is going to be my answer, and then everything else is to help me solve the problem. So the first denominator will be x minus 3. The second denominator will be x minus 3 squared. And the third denominator will be x minus 3 cubed. Okay? And of course, this will be A, B, and C. And by the way, if you use different letters, or if you put your letters in a different order, you'll still get the same answers as me. Okay? All right. So now, this guy has the common denominator. We do nothing to him. Okay? This one, I'm going to multiply by x minus 3, top and bottom. And then this would be times x minus 3 squared. Okay? And that's going to give us x minus 3 cubed, x minus 3 cubed, and x minus 3 cubed. It's going to give us a common denominator. Now again, we learned from our first example, we don't actually care about what happens here. We only care about what happens in the numerator. So what I'm going to do is I'm going to take my numerators and write those down. So I've got x squared minus 4x plus 7 is equal to, and I'm going to go ahead and expand this. So this is going to be a times x squared minus 6x plus 9 plus b times x minus 3 plus c. And we're going to go ahead and we're going to distribute. So I get ax squared minus 6ax plus 9a plus bx minus 3b plus c. And just like our first example, we're going to combine like terms. So if I combine like terms and create equations, I'm going to get x squared. Well, I'm going to drop the x squared because everything I grab is going to have an x squared. So what I end up with is 1 equals a. Because the only term with an x squared is this one. Then I'm going to take my x terms. So I get negative 4 equals what? Negative 6a and plus b. Okay? And then I'm going to take my third one, my constant term, 7 equals, and I've got 9a, and then I've got minus 3b and plus c. Now this is a fairly simple system to solve because I know immediately a is 1. So if I sub a 1 in here, this is negative 6. Okay? Add 6 to both sides, and you get b equals 2, hopefully. So far, so good. Then what? Well, if I put a 1 here, and I put a 2 here, that's going to be 9. Minus 6, that's 3. Okay? Subtract 3. Hopefully you get c equals 4. Okay? So we're solving a system of equations here to get these three answers. Once we solve this system to get these three answers, we take what I've got in blue and substitute these three answers. And so I end up with 1 over x minus 3 plus 2 over x minus 3 squared plus 4 over x minus 3 cubed. And that is the partial fraction decomposition if you have repeat linear factors. Not unique linear factors, but repeat linear factors. And so if you have a denominator that's squared, you'll put the first power here and the second power here. If you have one that's cubed, you put the first here, the second here, and then the third here, and so on. I've not seen too many beyond that, but if you did, that's what you'd do. Okay? All right. A special case is every now and then we get something like this. 3x cubed minus 3x squared plus 7x minus 4 over x squared minus x. Okay? Now, this is a special case because the top is actually bigger than the bottom. And so instead of trying to decompose this, again, kind of likening this to our elementary school fractions, this is like saying you've got 17 over 5. Okay? What you would do is see how many times 5 goes into 17 and rewrite this as 3 and 2/5, and then try to reduce this. Does that make sense? So how do we do that with polynomials? How do I see how many times this goes into this? And the answer is long division. So here we go. 3x cubed minus 3x squared plus 7x minus 4 divided by x squared minus x. And remember, we always divide by this and then multiply by both. So how many times will x squared go into 3x cubed? So you can 3x cubed divided by x squared. Remember, 3 over 1 is 3. And we subtract, so 3 minus 2 is 1. So this is 3x up here. 3x times x squared is 3x cubed, and 3x times negative x is negative 3x squared. Okay, negative 3x squared. Then what? Then we subtract. Always make sure you subtract. Lucky for me, both of these go away. So then you ask yourself, how many times will x squared go into 7x? Well, it won't. So that means my remainder is 7x minus 4. So this fraction here is equal to 3x plus 7x minus 4 over x squared minus x. And now we're going to do partial fraction decomposition on this fraction. Okay, so here's what we do. We take this fraction, just like before, and we factor. Okay, what does this factor into? X and x minus 1, right? X and x minus 1. So now that we've got x and x minus 1, we say that this, now don't forget this 3x, is equal to 3x plus, okay, and 1 will be x minus 1, and 1 will be x, and this will be a, and this will be b, and this part here now becomes just like our first example, which is you have two unique, go ahead and put 3 there, two unique linear factors, okay, two unique linear factors, okay. So now what do? We do the same thing we've been doing, which is, what is the common denominator? Okay, this guy has got to get multiplied by x over x, and this guy has to get multiplied by x minus 1 over x minus 1. Okay, squeeze that in like a bad math teacher. Now, what does this become? Okay, this becomes, and really again, we're really worried about this part right here. The 3x's are the same, the denominators are the same. So we end up with something like this. We end up with 7x minus 4 equals ax plus, and I'm going to go ahead and distribute this. And so I'm going to get bx minus b. Okay, ax plus bx minus b. Okay, so then what? Okay, so then what? Well, now combine our like terms into a system. So I get 7 equals what? A plus b. And then I get this, which is what? Negative 4 equals negative b. Well, that's easy. B equals 4. Well, if b is 4, 4 plus 3 makes 7, so a is 3. There's the two answers to my system. By the way, do you see why this is in the chapter with systems of equations in every pre-calculus book? You got to know your systems of equations. So I take what's in blue. I take this right here, and that's going to give me my answer, which is 3x plus what? A over x minus 1 plus b over x. That is the partial fraction decomposition for this original fraction. All right. So here's our fourth example and our final case, which is you have 8x squared plus 10x minus 3 over x plus 4 times x squared plus 1. Now I want you to note this does not factor. There's a lot of folks in a hurry will say, oh, x plus 1, x minus 1. That's if it's x squared minus 1. This does not factor. Now, if this does not factor, we get something unique. Okay, this time we get a non-linear factor. This is a very special situation. You get a nonlinear factor. And what I'm going to do is I'm going to show you how to handle this. So here goes. Just like before, we're going to take this and we're going to say, well, we got two factors, so we should get two fractions. First fraction will have a denominator of x plus 4, and the second fraction will have a denominator of x squared plus 1. Okay? Where this will be different is up here you will get A. Up here you will get bx plus c. If you just put a b here, this partial fraction decomposition will not work. And I'm going to try my best to explain why. Basically, what you need to remember as a student is this is a first degree. This is going to be 1 degree less. And so all of our factors from the first example to now, you had a first degree polynomial in the denominator. That's going to give you a constant in the numerator. So an a, a b, a c. Because this is second degree, you're going to get a first degree in the numerator. Okay? So, here goes. I take this, and just like before, and really this is the only new thing, is this setup right here, specifically that, I'm going to find a common denominator. So this will be times x squared plus 1, top and bottom. And this will be times x plus 4, top and bottom. And I'm going to write out the fraction that gives me. And that's going to be my partial fraction decomposition. I'm going to use it to set up a system of equations. So I get 8x squared plus 10x minus 3 equals. Now, I'm going to go ahead and distribute this. That distributes to ax squared plus a. And I'm going to go ahead and use the FOIL method for this. And this is going to give me bx squared. Okay? And then it's going to give me cx, and it's going to give me 4bx. So cx and 4bx. And then I'm going to get c times 4, which will be 4c. Okay? And just like before, we're going to put all of our x squared terms into an equation. So 8 equals a plus b. We're going to put all of our x terms. So we're going to get 10 equals, and I'm going to say, what have I got here? Cx and 4bx. So I'm going to say c plus 4b. And then I'm going to take my constant terms, negative 3 equals what? A plus 4c. Okay? And then I've got to find a way to solve this system. And so what I'm going to do is I'm going to start with, let me grab a different pen here. I'm going to start with these two. And I'm going to say 8 equals a plus b. And I'm going to multiply this one by negative 1. So I'm going to get 3 equals negative a minus 4c. And when I put that together, I'm going to get 11 equals b minus 4c. So I get a new equation. Now that doesn't seem really helpful, except I've got this, and I've got this one here, and they both have b's and c's. And so I'm going to say, okay, cool. Well, this is negative 4c. So if I take that equation, 11 equals b minus 4c. And then I take this equation here, and I multiply by 4. I'm going to get 40 equals 4 times 4 is 16b, and then 4 times c would be 4c. And what that does for me is it gets rid of every variable except b. So I get 17b, and 40 plus 11 equals 51. Okay? And, you know, I stole this from a book. When you do all of this math and you get these numbers that look like that, 17 and 51, and you say, ooh, that's not really pretty. But lucky me, 17 goes into 51 3 times. Okay? And that's kind of how you know that this is from somebody's math book, is because, well, you know, or you took the time to sit and make one up that worked out real pretty. B equals 3. Okay? Well, now that I know b equals 3, I can come back to this equation, plug in a 3. So you get a plus 3 equals 8. That gives me a equals 5. Okay? And then, okay, I've got a equals 5. I've got b equals 3. I can solve for c, whichever one I want. I'm going to use this one. So I'm going to say 4 times 3 is 12. C plus 12 equals 10, so I'm going to subtract 12 from both sides, and that gives me c equals negative 2. Okay? So I get something like that. Now what? And now I go all the way back to the top. And notice I wrote this in blue, and then I did the rest of my work in pencil. I'm going to take what's written in blue, and I'm going to say, okay, that is my answer, x plus 4, x squared plus 1. And A is 5, and then BX, and it says plus C, but plus a negative 2 is going to be the same as minus 2. Okay? Oh, I wrote B. That's why you don't do math in pen. 3x minus 2. 3x minus 2. Okay? That is the partial fraction decomposition for something that has non-linear factors. Okay? And the secret is that your numerator is always going to be 1 power less than your denominator. And so if your denominator doesn't factor and you have a square, you have to have a linear function, right? Bx plus c in the numerator. Okay? So anyway, that is partial fraction decomposition. That's the 4 different cases you can run into. I hope this helps you. Please give it a try, and let me know if you have any questions.